running around town in the rain last couple of days.
Yeah.
I know, I have a meeting set up on Tuesday and it's a rain day too. I'm like, oh,
Yeah.
jeez.
Driving in downtown LA is not fun when it's raining.
No. You're driving from where? Orange?
No, Hermosa Beach.
Oh, yeah.
So
I mean,
it's really close. So like when I went there,
Are you guys movers when you're presenting?
I'm not. I don't think I am.
Because what I can do is I can do a picture-in-picture, so you can be up on the top talking, and then the rest of the screen will show your
I mean,
presentation.
it's whatever, it's up to y'all.
So we can accommodate for modesty and shyness.
I mean, we're salespeople. We're thrown in front of people all the time.
All right. In that case, you're perfect where you are there. And then once you're ready, I can switch to your presentation.
yeah, it took me 30 minutes to get to downtown to go in there, but then on the way home, it took an hour.
Oh, man.
Yeah. But usually I can get, downtown LA is probably my favorite place to go.
I mean,
Because
my
from
place
where
is
I
so
live.
convenient to go in and out of downtown. I can side street it the whole way,
Nice.
or take the freeway if it's not terrible. So
Yeah.
it's pleasant for me,
Nice.
especially the Dodger games. It's even closer to my place. I'm just like,
Oh, you live up there? Like
yeah,
in that.
I live maybe 10, 15 minutes from the stadium.
Okay. That's cool. So you split time between the two places?
I just come down for meetings and I go back. My daughter still wants me around overnight and stuff.
Oh,
so
okay.
I just do my meeting and I hustle home.
Oh, well.
And Lauren kind of handles stuff as much as she can when I'm running around.
Here's some scissors.
How long's that drive?
3 hours.
3 hours?
To here it's 4 hours.
Solid.
Almost 4 hours.
4 to here?
Yeah.
Yeah.
That's why getting to meetings here is rough.
Yeah. Yeah.
Like
East
it's
LA.
possible. It's just rough. 3 hours seems to be just enough. Like I can get out of the house around like 8:30, latest 9, and still make a lunch meeting in downtown,
Mhm.
and then still make it home before like dinner time 6.
Yeah, okay.
Yeah.
Yeah.
Latest 7.
3's like, it's not the worst.
Yeah.
Like,
Yeah.
it's definitely manageable.
Yeah.
And we don't, you're not doing it all the time.
No.
So.
It's. I mean, it'd be impossible to do all the time.
Yeah, yeah. I
Like,
knew
there
some
was-
people that were commuting from Sacramento to SF every day. A lot of people did that. I mean, technically it is like a 2.5, 2.5, 2.5.
Yeah.
But it's never to a 2.5 drive. I've done it. I've tried to do it before, like after work.
Hi.
Hello.
Every time that I come back to
Yeah, it's always like,
trying to
That's a wild.
yeah, I was like,
that's a
people,
wild
people
deal.
commuting. Yeah.
help me to
Again, an hour is like reasonable. 2 hours is pushing it. But
and I
yeah.
Yeah.
3 hours is
it
like.
says it's not out.
In November, I did it
And then it says
back-to-back
you
days
said it,
because that's
and then
like
it
it was
says
these
it's
meetings that I was trying to get in the books for a while. It's like, so just
Oh,
did it
no.
back-to-back. It was so rough. Like my body just hated me for it.
Oh man.
Yeah.
Yes.
So you drove all the way and then
And then did it again the next day.
I would have at least one night, but stayed at a hotel.
I mean, I have a place here, so that it
Oh,
would be
yeah, you
easy
could've
to
just stayed
stay,
it there, yeah,
But
right.
I mean, this little one, man. But yeah, we need to figure out how to get her on her own overnight. I think my husband's scared, honestly. Like, he is scared.
How are you?
What's going on?
Good.
How you doing? Good to see ya.
Hello.
Oh, I'm sorry I stepped on you.
It's okay. It's sorry. Good luck.
How are the babies?
She's
The baby.
The baby.
Yeah.
She's good.
Yes.
Yeah, she's. I mean, she's a little toddler now.
Yeah.
Like, running around, having fun.
Did you go to Michoacan?
Not yet.
Oh, okay. I thought you guys.
No. We went to Mexicali for Christmas. That's where her uncle is.
Oh, okay.
Yeah, and we went like the week before Christmas, and I was like, I think it was just when the whole family from here could get time off to do it. And I'm like, it is so frazzled.
Really?
It's because everyone's doing holiday shopping, and
Right.
there's just so much going on. I'm like,
Mhm.
can we not go on a big old holiday weekend?
Yeah.
Yeah. Mexicali has developed so much. Like even in like the I would say a few years I've been with my
By any
husband or
chance,
whatever.
do you guys know what these numbers are?
No,
Okay.
it's either gonna be hero meat, chicken shawarma, or falafel. That's all
Hero meat?
Yeah, Hero.
Oh, gyro.
Hero.
Got it.
Nice.
Yeah.
I just
Oh,
went
yeah?
to Mexicali like
Yeah, man.
in February.
Good to see you.
Recent.
I love
So
Mexicali.
gyro,
fun.
chicken
Yes.
shawarma, or
Hey,
what?
good.
Hey, how's it going?
Yeah, good. Good to see you,
I
man.
love
See you
Mexicali.
too.
So calm.
It's chill.
Chill.
Yeah. Well, not before Christmas, but
Yeah.
yeah.
It's not
I can
even
imagine.
yet.
Before
It was
Christmas.
cute though. Like the one thing my mother-in-law wanted to do while we were out there was to take family photos, and like you know, it was a lot of the family members like just getting us to one spot, and it was like in the mall the weekend before
You guys see
Christmas.
that, Gavin?
But we did take it, and they were
You
the
guys
greatest
see it?
photos.
I bet.
And I was like, okay, if this is the only thing that was the result of this trip, like, all right, yeah. And whatever reason, the photographer, he got my little one to smile so big and
Oh,
like
nice.
all the pictures came out so cute. It's funny because like you know my mother-in-law was just gonna get like one or two, and of course she like got the whole package. It's
Of
like
course.
her little grandkids looking all cute. And I was teasing like whatever filter they have, I love it. You can't see my freckles. Like everyone had perfect skin. We even dressed up or anything. Like it was
Yeah.
so last
Gyro
minute.
is lamb.
Like so.
Well, that's
You
good.
know,
That's
yeah, it
good.
was good.
It's a Mediterranean taco.
All right, let me go get something.
Yes,
To eat. 'Cause
absolutely. Yeah.
starving. I don't know why I'm starving
You
today.
are
Did you see breakfast?
about to
I did
have
not.
a mind-opening experience. Okay, I'm only gonna explain this once, okay? Just once. Chicken shawarma, Euro meat, falafel. Sorry, it's gone. I don't remember what I said.
There should be enough. I ordered 24. I thought Josh was coming for a half second, and I was like, whatever. There's extra.
Oh, Josh was. Did he say he wanted to go?
He like loosely said, "Oh, I should be back by Friday.
Oh.
I'll tag along." But then I think he tacked on
It's like grains and rice.
Taxider's visit, and then his flight got all delayed or whatever. So I don't even know if he's back.
It's street food. I mean,
It's fine.
all-
I was like, we'll have more. You can tag along the next time.
Yeah.
It's all glorified Mediterranean.
He'd rather go to the food truck stuff anyways.
Who?
Josh?
Really?
Some things are just
Okay.
universal.
And like a lunch and learn? I don't know.
Like, top
Oh,
of the
oh
ingredients.
yeah. No, he wants to be at the handshake thing. Not,
Yeah.
Not the
Not the
stare at us,
presentation.
talk about
Yeah, just sit
Cooling
here.
Towers.
Yeah. What's up, Jackson?
Hey. You can do our lunch and learn, Jackson, since we just sold one. I said you could do the lunch and learn since you're super familiar.
We haven't installed it yet.
Well, maybe some of it'll still be good then. Yeah.
So you buy my Alright. Chicken shawarma, Euro meat, falafel.
I should have made signs. I didn't know that they wouldn't be
It's
written with what is on there.
They never mark them anymore.
I'm gonna take a Sprite.
By the time they find this room, the person's usually pretty overwhelmed and just wants to drop off some food and get out of here. So, and I didn't do anything bad, but
It's like, this
sorry.
guy taking me into this back corner room.
We've gone through like 6 doors,
Yeah.
parking lot.
Oh, that's a little one.
It's really
How many months
get
now?
what we're
It's
going
gonna be
for.
7 next Friday.
Fun.
Yeah, so.
Solid food.
Yeah, we're trying.
Yeah, it's a process.
Having a good year?
He's like, no, I want mom and milk.
Yeah, it's not.
Good.
Rounded away.
We tried carrot.
Good busy, right?
A whole bunch of
Yeah.
stuff.
Alright.
Yeah.
Not too many
When did
problems.
yours start?
Not
getting
yet.
Okay.
I'm
My
running
little
a
one's
big
always
job,
been
so it's like
great
a lot
eater
of
slash
pre-construction, but
nurser.
not a lot of like,
So, yeah,
not a lot of
background's
actual
not.
construction, so
Yeah.
it's like
And
more
then-
staring
Remember
at
the
the
first
screen,
floor day?
less
This is like-
early morning calls.
Yeah,
Like sweet
But-
potatoes?
Or late.
But one we
late
made
evenings,
ourselves.
but less
Yeah.
early
Tried
morning.
that.
Oh,
And then,
But get a deal with
I think like
engineering.
pureed
Huh?
pear.
Yeah?
We tried
He's like,
bananas first.
Engineering is fine, but
And
the
then
other
sweet
engineers like.
carrots.
Yeah.
The outside ones?
Yeah.
Maybe I should
Maybe it's
not
just too weird.
talk about it.
Agreed. Let's keep this conversation.
Yeah, I think it's just like, we need to get more into the
How's it
habit
going?
of doing it because I think it's just like the ritual. He's not
It's
used
the
to
VIP area.
taste, so we gotta be more
Having a bottle, I'm having a bottle ticket.
Eventually, yeah.
Just kidding about the
Yeah,
bottle.
that's exactly the point, yeah.
Is your wife still nursing or?
We've always been doing formula.
Oh, okay.
So,
It's a little not so stressful on it.
yeah,
Yeah.
it's been nice. Because my sister-in-law was nursing.
It's
You just
rough.
walked by Ford.
Like,
Yeah.
it's best for the kiddo, but it's rough on them.
Yeah.
Yes, I am.
I know, I always tell my husband, like, I think we did everything the hardest way possible. Like, it's supposedly the right way, but like the hardest way possible.
Oh, my
We had
announcement.
tried to do it, but it was like a month and a half.
Good, I almost threw up making that public speaker.
Hey!
Afternoon. What's up, man? How you doing?
Hey!
Are you gonna get some food?
The left side is falafel here. The right side.
As long as he's happy and healthy,
Yeah.
that's all that matters.
I think I might just a pretty thin guy. I don't need that much stuff.
Cooling Towers is popular. Or my our lunch is popular, one or the other.
I don't tell people what we're eating.
Oh, okay.
I don't like to get in the mix of what we're eating or not eating, and so I take no complaints, I take no credit. I let them go directly to you, and hopefully they don't. I try to, for me it's free lunch, so keep your mouth shut.
Yeah, I always like to feed people warm food, like,
Oh, yeah,
it's
yeah.
just, I don't know, that's just me too.
No, this is nice, this
Yeah.
is good, and thank you. I'm just saying.
Okay.
You're not eating?
They're here for you. I'm on a weird, I'm doing a carnivore diet.
Eat the meat.
Yeah.
My husband does, let's stick around it.
Let's see how many.
I mean, I booked 24?
Yeah, I think we'll have go. Exchange my life.
What happened?
The carnivore diet. I know it's a total trend or total fad.
Oh, we've done
I
it.
heard it works.
It works.
Yeah, I feel
You
good.
don't get those spikes. It's real nice. Yeah, it's just I have cravings for things you're not supposed to be eating.
I did it like 8 or 9 years ago. I did like a low carb thing and dropped a ton of weight. Then slowly gained it back up until December, and now.
It's nice to know that there's it's nice to know that there's a strategy though. You're like, oh, okay, I'm gained a little bit. Let me just do it. Yeah.
It makes you less fun at certain events, right?
Barbecues are fun.
But we did. My father-in-law turned 70, and so we went out to Fogo de Chao for his birthday.
Oh, you're like
That's your spot right
you're
now.
like that salad bar? No.
Yeah, I just fasted for 24 hours. We're going green. Bring it on.
Green all day?
I think I forgot it was my father-in-law's birthday.
You're like, it's my birthday.
Hopefully that point we'll talk to you about it. Oh yeah, I have the same.
Wait for David.
This has been.
We also super good friend.
I like Friday lunch mornings. Everyone's kind of
Everyone's in a good mood.
That was February 2019.
Free food on Friday?
I think I just get traffic in between us. But the last time,
Nice little turnout we got here.
it's about
I
7
like it.
Outside and then
Oh yeah, I think it'll be good. Stuff in there. Like, we've sold some of you and Jackson and some other guys, so I think some of the installation.
A lot of people will do it for like it's really but once you kind of get used to it, it's like 2 cells are very clear what to do. It's hard to pack
Oh, and you can get it? Yeah, this was not an issue, right?
I've also been exercising.
No, lock up the door. Can you get it from the inside, or should you climb in the inside?
I agree, moderation is probably the best way to do it. That doesn't work for me. I get really drawn into It did fast. So the same bottom section. You're supposed to put bolts through there. Sure. If I get the first, you get like the first 2 or 3.
I told them forever, no one's really asking for it.
What's that?
So you sound like you're figuring out.
Or those bolts aren't going in.
Or they're not going in. Well, I mean, 3 is probably suitable, but yeah, that's Red team, we're gonna get started, that's all right. It's a little 5 after 12. Or we can just keep eating.
Let's just eat.
Okay. Alright, I'm just gonna talk, you guys can talk too. Some of it's sticks and it's all good. It's Friday, and it's sunny outside, so we're having a good time. You guys already know Alan's over here, McDermott. That team's with me, Christine Alonzo, and we are your outside sales team for you guys. So you also have access to our inside team and everyone else in the office. But
You guys got basically more people.
yeah, which is great, you know.
Yeah.
Like, the rest of the office and the other accounts don't really have that, so we hope to be of service. So today we're going to be talking about vacuum cooling towers. It's really funny, when I first started running around, maybe 20 years ago now, and I'd walk into some offices, I'd be like, oh yeah, I sell vacuum cooling towers, and one of the guys like started laughing in my face, and I was like, what? I did a small shop. I'm like, no, we're like a super giant worldwide company, like WTF. So, you know, if you didn't know that. They are, and they're ever growing. So, you know, even in the down parts of the market, they're always like keeping up, you know, other factories or other, you know, resources like coil making and air coils. So they've grown tremendously. Vertical systems is pretty cool because we've been the rep for VACA since they first started operating in 1976. Like not vertical systems directly because we transferred names from Dockendorf to vertical, but they're single rep, which means we have a great relationship. And
What do you use?
WD Dockendorf? Remember Dockendorf?
No.
Oh, okay. Yeah, anyway, this is like 25 years ago or something. Yeah, so Dockendorf started with VACO and then he partnered with the rest of the vertical guys and then we became vertical. But the great part is we have like all this backlog information about stuff we sold, what the competition has sold since the 1970s. So, you know, we've seen it. And we likely have at least some information on it. So, you know, and VACO is just a great company and we hope to explain how we can help you and how, you know, it's funny, like, maybe I want to say too, one of the best companies for that. Actually responsive and we'll jump through the hoop for you guys and we'll go through the details that we need. So, yeah, it's a company I'm proud to represent because we're able to accommodate whatever you guys.
They invest both us and you guys too, so like they do just training for us to gain knowledge at their factory or bring you guys out here so when they go get hands-on experience and see some of these tires being built, they always want to have a look. And they put you up, they do great presentations.
So today we're just talking about kind of cooling tower basics, pretty much what it is, what rapid cooling is, what kind of applications are you really looking for when you know you're seeing cooling towers. We'll go over really quickly how to select them, what we're looking for as far as you know footprint, and when you guys do a ton of retrofits, so you know there's additional considerations to that. Obviously, you're installing contractors, so we got some pointers for you. I can answer David's question. And then Title 24, because we live in sunny California, we pay that sunshine tax. And then we have some pointers on care and maintenance, but if you can't get through that, it's not the end of the world. So what's the goal of a cooling tower? We're going to use evaporative cooling to reject heat into the atmosphere. So typically in our business, it's taking the heat from the building and putting it outside. If you're doing any kind of industrial process, same thing. We're taking the heat from the process and trying to reject it out into the atmosphere and out of your system. So how does evaporative cooling work? I just like to use analogies. You know, like if you're running around, you're getting hot and sweaty, your sweat beads, they evaporate, which takes some of the heat from your body and rejects it to the atmosphere. And then when you jump into a pool on a hot day, you come out and you cool down. So, you know, the hot air mixes with the cold water droplets on your body, that evaporates and causes a cooling effect. So the latent heat is transferred as the
the water turns into vapor. How much of that heat is released is all determined by our first law of thermodynamics. Not get into that too much. So this is kind of funny. As far as cooling, a definition of a ton of refrigeration is 12,000 BTUs per hour. Nothing new there. But a cooling tower ton is defined a little bit differently. In addition to that 12,000 BTU hours from the cooling, we actually also accommodate for the heat of compression. So, while your chillers or your heat pumps are cooling, it's using the heat of compression to, facilitate that refrigerant cycle. So we also have to reject that additional heat from the work caused there through our cooling towers. So cooling tower is actually 15,000 BTUs per hour. It's just something to be mindful of. So you'll see on the cut sheet, it'll say, a certain amount of BTUs, but if you divide it by 1,000 BTUs, it'll be a different tonnage than if you divide it by 2,000. But anyway, we'll sort it out for you, and we can explain it again if it gets confusing at the time of design. So the simplified version of the first law of thermodynamics, the amount of heat rejected is equal to our GPM times our temperature range, compression divided by cooling tower tons, 15,000, not 12,000. So, you need to calculate for your flow, for the amount of tons you're looking for. That's the equation that we use. All right, so there's pretty much two types of cooling towers, open and closed. So an open cooling tower, we do the evaporation through a direct cooling process where we use PVC fill pack, pretty much trying to suspend as much of that water in contact with the air for as long as possible. And there's two kinds of configurations that we do that. Counterflow, where that air and the water come into direct 180-degree connection, or crossflow, where they come in at a perpendicular 90-degree angle. So we do both, and they both work to reject heat. Evaporates have always been a counterflow fan, even though they'll supply crossflow. And these are pretty much the reasons why. In that direct 180-degree contact with the air and water, we got an even temperature gradient for the whole fill pack, whereas when it comes in at a 90-degree angle, there's a little bit of a uneven gradient as you go along the fill pack. This slide shows it. So this also requires more air to get, an even temperature distribution on the bottom. Oh, okay, so this is winter conditions. So, it's not as impactful for us here because it's so sunny all the time. But in the cold regions, you usually get a really cold spot in the outer corner, so that's usually the area where things freeze. But also, it's just nice to have this temperature, even temperature gradient. So when you draw the water out of the basin, you know that's the temperature of the water that you're getting. And you're not getting, 55 over here and 34 over here. I mean, it's all supposed to be mixed in the basin and everything, it's fine.
This is the temperature of the fill?
Yeah.
Okay.
Yeah, because this is the gradient inside the fill.
The water inside the fill. That's what trickles down. Yeah. Yeah, so the main concern for at least is the freezing. So there's more potential for freezing in this configuration versus the counterflow. So because the crossflow, the 90-degree one, requires more air to do the same amount of cooling, it usually needs a bump in horsepower, or it can need a bump in horsepower. So if you're trying to find, lowest electrical connection or, operation cost, sometimes the counterflow can come out on top. The other advantage between counterflow and crossflow is the ability to use your area. So if you're in a well, and the counterflow can draw air from all four sides. So usually I can fit a smaller unit in there and utilize that area. Whereas the crossflow, because the fill is only on two sides, we only draw air from two sides. So instead of using all of that area, I'm only using the dark blue. So this, splash area is kind of like, not useful air, so it just sits there. So this also requires more overall footprint to get the airflow because I'm only using a portion of the well versus the whole thing. So the counterflows also generally tend to be more compact. It can be taller. I would say that's a potential negative if you have some line of sight or something with an architectural consideration. But generally our footprints are much smaller than the crossflow because of the air configuration and just where the fill is sitting. That being said, Adaco does sell everything. So you can get one or the other. So there's pros and cons to each. But we do definitely gravitate towards the counterflow for the reasons just described. But the crossflow does have special applications where it makes sense for footprint or height or just something different. Adaco also sells this solar cooling tower. Probably never.
Have you ever sold
I've sold hundreds.
I feel like I've been to the factory and I never sold.
Yeah, I don't even
Yeah,
know
I
what
think
this.
they sold like 2.
Bad joke.
Yeah. But I mean, you know, it would have to be the right customer, the right application, the right, I don't know, some sort of PV incentive, something, but yeah.
Because I'm not sure if you mentioned it, but like the counterflow and the crossflow, usually counterflow for most applications, you're like 100 to 500 tons, right? The counterflow is only going to beat everything that she said up there. Really, when the crossflow starts to make sense is when you get into those high tonnages, like when you're doing these big central plants, you know, these 1,000-ton like crossflow towers. It starts making a lot more sense. They can be up against each other, save space, and then just a little bit. You don't have to worry about air. I think you might go into this.
Yeah, I think it's like one of these design considerations things. But yeah, I would agree that the crossflow is more on the higher tonnages. And then you have a lot of space. Like our job is not a lot of space, so it wasn't gonna work. But yeah. Yes, but. Yes, but. Yeah. Okay, the other type of cooling tower you see, and I think you pretty much only really see this in replacement, is force draft. So the previous style was induced draft, where the air was drawn through the fill. This one, just like the name is, we're forcing the air through the fill instead. They're always going to be higher in horsepower because they have to overcome all that static going through the cooling tower. But they do have their place in specific jobs.
I'll echo that. They're prohibitive from an energy cost standpoint when it's force drafted. So, new construction, even replacement, that's something.
Yeah.
There's allowances to replace it like for like, but just be careful if you're looking at stuff like that.
I think like for like you can kind of.
I think so
There's an
too.
exception.
Yeah.
But yeah, I think it's. I have a slide on it. It's on slide 24.
Okay.
Yeah. But I think it's.
Yeah, just in case someone's looking at this and like, oh, I got a job, I'm going to use it on that. Don't put that away. Don't do that, please.
Yeah, or let's look into it because I think there are some exceptions. Pretty much like you can't really fit anything else in there. Like we're going to do this. So, but yeah, like code is starting to push back because it is just so obvious that these require much more energy to operate through how this life. We got all the different kinds. This is a low profile. I guess this is going to be the one. Yeah, so low profile is definitely where this has been used. I think on the Natural History Museum is one of these. The Charles Jammer, which you guys installed too, is one of these. But that's because of fit and space. So they do have their places because sometimes it's the only thing that'll fit was the space that you got. Or it's inside and it's plenum out. The discharge is plenum out of the building. So you would need a force draft fan to push the air through that duct. But yeah, yes. So higher horsepower, but yeah, tight layouts, low height. It has to be a driver. Like it won't be your first go-to. Like we'll probably try one of those induced drafts and we'll run into it. Yeah, you're gonna put my solar cooling tower out there and you're like, hey, this doesn't work. I'm gonna go with my force draft. All right, so those were our open cooling towers. So what's a closed? So the open one had the open fill where the air comes in direct contact with the water. Indirect or closed coolers, the cooling medium is inside the coils, and the water is sprayed over the coil to indirectly cool your whatever is in your processed water. I guess this is a better diagram of that. So So yeah, our hot water comes inside the coil. So the water coming in and out of our system, so whatever heat pumps is all in a closed system, and then a separate water spray will drench that, do the rapid cooling, and indirectly make the water in the coil colder. And that goes, it really, in a good way, overtakes cooling tower. So most of the competition just does regular bare tube circular coils. The DAF will figure it out if they just smush the coils into an elliptical shape, they get more surface area, and there are also less air resistance going through that coil. So you get more capacity, and smaller footprint and less horsepower. And then they overthought it more, and they actually rib the interior of that coil. So this is more traditional with that's usually copper, right? They're doing this with galvanized steel. And this is why they won't even let us see it when we go to the factory. They have it behind this big old wall. And they're like, hey, we're going to like rip the coils, but we're not going to show you how because it's like proprietary or whatever. But, you know, it's the little things that get them just a little bit more extra capacity, you know, to get in an even smaller footprint. So one of our products, the ESWB, combines both open and closed cooling. So we'll put your closed loop here on the bottom, also have additional fill. So when we do drench the fill, we drop the temperature of the water a little bit. So now I have a colder water here to cool the rest of the coil for the process. So that pretty much gets us more capacity again. Our goal is always more capacity and smaller footprint. But the additional set of fill does make it colder. So that would be the trade-off. So similar to the open ones, we have induced draft products where we're drawing the air through the unit, and then we have forced draft products where we're pushing the air through the units. And the considerations are pretty much the same. You know, so probably never start at a forced draft and then end up there because of some driver, which is usually space or height or something very unique. All right, applications. So open towers for our business is 99% of the time it'll be attached to a chilled water system. So condenser water loop coming out of the chiller is going to be sent to our cooling tower to get cooled down again and be used in the cycle, right? So you'll probably see them on large tonnages, like 500 tons and up. I mean, I would go air cooled at 300 tons and below, honestly. So yeah, you're looking at larger applications, applications with high approaches, temperature approaches that you need, and sometimes in big batch cooling and industrial applications. But yeah, 99% on chiller, and we're off to the races. So the reason why we use open cooling towers on chillers is because the direct cooling is more efficient, so it's the best bang for your buck as far as the size that you're going to buy and the cost that it's going to take to use capacity. It's lowest in weight because my heat transfer media is super light PVC fill. So it's low weight, makes it easy to put on roofs and other locations, and it's the lowest unit cost. And then sometimes if you still need to have a closed loop, we'll pair an open cooling tower with a heat exchanger, so then you can close off your loop. So that versus going with an entire closed circuit cooler. All right. Closed circuit coolers are mostly used on water source heat pump applications, sometimes other processes. So that's industrial too. So pretty much anything where you need to keep your loop closed. You know, water source heat pumps have very small heat exchangers versus that really big chiller that you can just, you know, brush those tubes that you're never going to get to that heat exchanger, or you just replace the whole unit. So it's imperative that you keep the closed loop clean and the heat exchangers from fouling. So yeah, that's where we'll see. Yeah, we're going to do that. I guess the other thing is you can cool other kinds of fluids. So if you're not doing water, you're doing, I don't think I've ever done oil, but you're doing propylene glycol for something cold or for whatever application that you're using. If you are, if your cooling medium is a refrigerant, It changes the name from a closed circuit cooler to an evaporative condenser, but same thing. You're just putting refrigerant through those tubes. And we've worked with you guys to replace a few vacuum condensers as well. But the technology and what's happening is the same. If you're working with something that's super high temperature, that's usually a process thing, that's also where you go closed circuit cooler. I can't put 170-degree water over plastic fill, it's just no thing. So, you know, but those are rare. Yeah, Oxpod, I know Brian does into it a little bit, but yeah. We're OSP pre-approved for both our AT and our, pretty much our crossflow and counterflow. The back was also really nice where pretty much all of their options are included in that OSP, so it doesn't matter what material you use, it doesn't matter which fan you choose, it's all covered under the OSP, so we can pretty much do it. Seismic is really our concern. So usually if you're doing a hospital, you're going to want to upgrade to the like upside structural. But pretty much Evapco can build a unit that can comply anywhere in the United States, which is nice per IBC. And then those values, these SBS numbers, they're determined by your structural engineer. So they'll tell you like, oh, I need a SBS up to whatever, 5 Gs, and I provide you with an upgrade design. Or if they say, oh no, you're good at 1, then we go with the standard design. So we just got to know which one you want. For sound sensitive applications, this is our go-to solution, our super low sound fan. So we replaced like our 8-bladed fan with this single piece 3-bladed fan, kind of similar to what you see like in a submarine, and then we reduced the speed. Instead of 1800 or whatever, running down at like 1100 RPM. So much slower, but big volumes of air. But it allows for a 9 to 15 decibel reduction in sound while not having any thermal performance degrade. Sometimes the low sound fans, they don't draw in as much air, so the capacity drops. So we don't have that problem. There is a dimensional impact that usually gets taller by 13 to 21, 24 inches. So just something to be mindful of.
What, you have 2 sound packages, or there's the standard fan, and then there's the super low sound fan, or is there an intermediate one?
Yeah, so there's the standard fan, there's the low sound fan,
Yeah.
which is in between, but there's a thermal beam, and then there's a super low sound fan.
Okay.
So the only reason you use the low sound fan is if the height for the super low sound fan wouldn't make it.
Yeah. Which is always, height is always an issue.
Height is an issue, right? So I would accommodate for that debate, make sure we have 100% or more, and then we go.
Okay, so standard, low, super low.
Yeah, and then of course the competition, it's the same thing. They brand it as like whisper quiet or super low or whatever they call it. But yeah, I think if sound is really important, if you're doing work, slap on the decibels on somewhere on the schedule or in spec. Otherwise, someone will bid a standard fan to low.
What was really
FRP, yeah. So yeah, instead of aluminum or standard fans are, they're now this big molded FRP single piece construction. Oh, it looks like that?
Yeah.
Oh, okay. I'm not familiar. Okay, if we need even more sound attenuation, we have hand water silencers. So after the fan noise, the next loudest thing is actually the water that drops into the basin. So it's a kerplunking all over the place, like a big old rain. So that's even too noisy for the acoustician or the.
That's white noise.
Yeah. Yeah. Right? Like, it's supposed to be like you're counting in your office. Right now it's a big tower. But for whatever reason, some people don't like it. So instead of just kerplunking in the basin, it'll catch it in a similar fill as our heat transfer media, and then it'll fall into the basin. But I mean, 4 to 12 decibels, that's pretty good. So yeah, it just depends. So that would be our combo. That's the fan and then the silencers. And then even if they want even more attenuation, they'll have like acoustical walls, which sold like once 20 years ago.
That ladder's not an issue.
Yeah. This is in Baltimore. I'll blame Maryland. Okay, so very good. I don't know. Anyway, materials. It's important to know what materials your cooling towers are. Well, one, it's the big dollar impact, so I know you guys are hyper aware of that. But also, there's a life and longevity thing. If you want it to last forever, 316 is the premium. It is also the premium dollar cost item. Definitely do not want to purchase 301 galvanized steel, because, or 301 stainless steel, because it's pretty much the same properties as galvanized steel, so you're paying extra for nothing. At minimum, you want 304 stainless in your basin. You know, that's where all the water is sitting. So at minimum, you want some sort of stainless in your basin. But you know, that's 1.6 times better than galvanized steel, and then 316 is more. And this is in pitting resistance. I think the next slide. Two more slides. Anyway, back to your basin. You always want some sort of stainless steel. Like, I would feel bad supplying you galvanized. And I know we do it because there's some projects where they just don't have the budget, and fine, we'll sell it to them again in 5 years and call it a day, right? But if we're doing our jobs right, you want stainless steel at minimum on the basin, and then you could do galv upper or 304 or 316. But
Which galvanized upper, stainless steel lower is probably
most common and like most agreed upon, like.
I love stainless.
Yeah,
But, but
stainless.
most common galvanized upper.
Yeah, so this is the before it was pitting resistance, and this is a resistance to chlorine corrosion. So compared to galvanized, 304 is double resistant to chlorine corrosion, but 316 is 10 times that. So pretty much the applications where you would justify using 316 is anything 2 miles from the ocean. You're close to the mesa and you got a cooling tower, we want to go 316. If you're near an airport where there's like jet fuel just hanging out in the air, or anything where you know there's some sort of like caustic something in the air, you want to do 316. Outside of that, I mean, maybe if they're a university, they want the thing to last forever, maybe. But, you know, more often than not, you're going to be doing 304 stainless steel basin, galvanized upper, unless, or even 304 upper is kind of common now. But 316 usually has to be a good reason. All right. So, I passed it out before, but it's been a minute. But I make these cheat sheets for how to design things, so we're going to go over real fast. So the conditions you need to select a cooling tower, definitely you need the ambient wet bulb because we're doing evaporative cooling. So that depends on how much moisture is in the air is going to drive how much evaporation is actually going to take place. And then in addition to that, I need 3 out of 4 of the following values. So you need your capacity, so your tons or BTUs that you need to project, your flow in GPM, and then your temperature in and your temperature out. If I'm missing one of those 4, I usually can determine the last one. So, and then, so that at minimum top left will get me, I can get you a cooling tower size and footprint and weight and horsepower. That's good. But the additional design considerations that will also drive your project, you know, is in an open or closed loop application. Pretty much, is a chiller or heat pump? And then, you know, am I in a well? You know, do we have clearances? Is there wind outside? Are we by an airport? Are we by the ocean? You know, like, is it sitting indoors? Like, how are we going to get it in there? If you're occupying, you know, these kind of things. So things that will impact the price of the unit and potentially the, you know, which one we ultimately choose.
You guys mentioned about exact replacement. Do you guys offer any kind of like customization to try to fit a certain package, footprint, or whatever?
Yeah, I think we're getting real close to there in the slides, but yes. So Brian told me to go over footprint considerations. So the footprint of a cooling tower I know is important because it's one of the biggest, physically biggest pieces of equipment on site, right? But it's always driven by our heat transfer surface area and the airflow required to do the evaporative cooling. So all we got is what we can evaporate, really driving the bus. And, you know, the amount of evaporation are driven by those 2 items. So I need the footprint to get those heat transfer surface area, and I need horsepower to get the airflow going. But I also need the air to also get it going. So these are examples of, the one on the left is in a well, so surrounded by 4 walls. We want to be below 400 feet per minute of downward air velocity to make sure that we have enough air to do it. And then if you have louvers in there, we want to make sure we have 600 feet per minute going through those louvers. Don't worry about it. Let me do the calculations for you. Alan can do the calculations for us so we verify that we have enough airflow. But it is a consideration on top of just regular maintenance, access, and all that stuff. Because if you don't have enough air, it's not going to evaporate the right amount of BTUs that you guys need. Other considerations, so you also don't want the cooling tower to be lower than any like adjacent walls or other buildings, because the wind, depending on which way it's blowing, can be so this is all saturated air, full of water, and then if I introduce saturated air into the cooling tower, it's not going to do any evaporation. So we're trying to avoid this. So one of the other things to be aware of when you replace or lay out a cooling tower, you want it to be even or higher than surrounding walls so that the air discharge, we're rejecting that heat from that saturated air way out of there. So, and usually we do that by, putting additional concrete base or fan cowl extensions. So the vacuum can provide this up to 3 inches tall without any additional support. But if you're going 4 or 6 feet, you just need some external support. But a lot of times it's a tag team between the two. Like you'll raise it 3 feet over here and then 3 feet over there or something.
How far off the wall does that go away generally? Like what's the dimension from the unit to the wall?
Backhoe, because it's because they're a factory, we'll say gap units. Yeah, so I'm getting there. So what's actually,
It's complicated.
yeah, well, okay, like our way that we do that is so you want this to be 45 degrees or more
From the
wall,
okay.
like here. Right, so this is probably, well, this is not a good example. It's probably okay, right? But if you look like right next to it,
yeah.
It's not good. But
Because typically screen walls cover the entire unit.
yeah.
And sometimes the shroud or whatever the top piece is called.
They're always going to say it's probably okay, but I can't guarantee it. That's the truth.
I guess a lot of screen walls
But
are separated.
if you're in that 45 degree or whatever, and it's not all the way down here, you're probably okay. Like if it's just a foot or two or whatever, you're probably okay.
Or it's tricky, and that's where it's nice to have some safety factor.
Yeah.
Because
Just overcoming capacity of it.
Yeah.
Yeah. But
I just feel like we never have enough space and we're always fighting for things.
And that wall being taller than the tower happens all the time.
But usually we do this, right? And usually this the extension is not the full width of the cooling tower. So, it gives you a little bit more on that angle if you're a little bit below.
But the extension's tricky too, because if it's more than 3 inches, then we have to externally support it.
Yeah.
So you'll do a 3-foot extension.
Yeah.
Okay, and it's 3 inches.
Yeah.
Okay. That's easier. But if it's more than 3 feet, that's us supporting that is a big pain. So we want to avoid doing that.
That's why it's usually a combination, right? I'm going to put it up 5
Do you
feet.
guy wires and stuff when you do that, or what does the support look like? Because can you connect it to the unit?
So you're doing posts, or you're coming off the wall, or it's a air hose. Usually you're trying to set it with your, I can't think of the word for the concrete piers. So usually you want your piers pretty high anyways, because it helps you with the piping, it helps you get some of that positive suction head.
Yeah.
Yeah, but
Putting it up 4 feet or more is good. For those reasons, you can get underneath it for maintenance for whatever reasons. You can get the equalizer connections that run there. Yeah, so there's some nice advantages to doing it that way. Yeah, all those things. You also need just regular service clearances. Generally that's 3 to 4 feet all the way around. If you have multiple cells going on, we also need airflow through the middle. So we'll advise whatever that minimum clearance is, generally 6 feet, but it depends on the unit. But we'll go through that. All right, my favorite. I need an exception to all of these clearance and airflow requirements. So can I have the tower right next to the wall? Can I put them closer together? And I want them to be flush. I only have 2 feet instead of 3 feet next to this wall. You know, my well is only this many feet by this many feet. Like, can I get away? Yes, and fine, maybe not. But a lot of those things are, you know, kind of what Brian said. Like, we know what the limitations are. A lot of times, you know, if you're going to put your cooling towers right next to each other, I can oversize it by the amount I know my airflow is dropping. My airflow is dropping, you know, because I'm putting it flush versus 6 feet apart. I'm going to see a 70% D rate. Let me oversize it to 10%. So something like that. So just talk to us. Like, it's just better that we designed it in versus just like slapping it together and trading for the dust. But yeah, it's usually a yes to make it accommodate some of these exceptions, but let's just make sure we design it in so you're not short on capacity when you're designing it.
We want to define that risk internally and then explain that risk to our customers.
Yeah, and also have the backup by like, oh, okay, like, I understand, like, it's up against the wall. I'm not going to get airflow on that side.
But putting that, because you can say it'll probably work, and that's still something we would want to define.
Good. They're probably pretty good about like, oh, I know I'm going to have a whatever 5% D rate.
Yeah.
We're going to set it to 7%. Yeah. Like you're probably okay, unless they're crazy. Unless there's a.
Just be ready for the crazy.
Yeah.
And it's not even that good thing.
No. Yeah. There's a prevailing wind that like brings everything up. But yeah, we can accommodate. Just, you know, there's always some wiggle room. All right, retrofit. Okay, so I feel like this is most of the work we've tag teamed together on with Western Allied replacement work. The first place to start is just send us a photo of a nameplate. And I think we're not utilized as much as replacing the other guys, but Apple's really good at finding replacement options for products that are not ours. So we are putting out a challenge to everyone to invite us to the table for replacing the other guys, any non-Evapco. Alan and I agreed upon $100 for bringing us to the table. So, and we're going to use the Scout system here. So don't like go into your computer and send me a nameplate from like 10 years ago. Okay? Send a real, you know, EAC, Marley, or whoever replacement nameplate, and then even better, bring us out to the job site so we can walk it and check it out. But like I said, we've been Evapco's first rep forever, so we know where we fit and we know where we don't. And if it's something that we're not a good fit on, we'll tell you up front, because there's no, you know, joy for any of us to take on risk where it doesn't make sense. But there's like 3 main cooling tower manufacturers and then some fiddly ones. And so, you know, we know where we fit and we know where we don't. But Evapco's very good at the catalogs are close.
The other 2 are VAC and Marley.
Yeah.
You're not, in case you don't want to say that a little bit.
Yeah.
Is that what that is?
Yeah, you'll never see that. That's not in Mexico and it's FRP. It's fiberglass. But they exist. But I'm telling you, yeah.
FRP's
never. All these reasons, you don't have to go through that.
It's a different time.
Yeah, different time. That's for cooling towers 201 or whatever. But yeah, so $100 for bringing us to the table, 400 extra bucks if we sell it to you guys. So there's a reason for this. Our office is doing a challenge between all the salespeople too. So we're going after the replacement market, and we also want to prove to you what we can and cannot do. And we're putting our dollars behind it and our skills and our tools and offering it up for you guys.
Sounds like you just raised our price by $100.
Well, these are going to your pocket and not on the project pocket. It's going to the PM salesperson, right? So I'll just give you a $500 discount and then no bonus on the thing. We'll figure it out. But anyway, well, it's $100 and you don't even sell anything. You know, like I don't know. Bring us to the table. We want to see it, and we want to, you know, put our best foot forward out there against the competition because we know that we can. Evapco back at their factory, they have this great Evapco logo that they assembled out of the competition's nameplate. Like, I know, it's aggressive. But anyway, that was probably a decade ago. So I think they're trying to do it again. But yeah, for the next thing on the retrofit, let us work the job because we're going to be looking for, you know, what the existing footprint looks like. We want to make sure that the space makes sense for the airflow that we need, and you know the size of our cooling tower, the weight. So that's all structural. And we want to look at the existing steel. You know, is that steel still reusable, feasible? Does it make sense for the new cooling tower that you want? You know, what's the pros and cons of replacing or reusing? Most times you want to reuse, right? Because that's a no-cost thing. But sometimes that's just not possible. And then if you reuse it, you got to make sure that the thing you slap on it matches it. So that's probably the biggest thing to look at when you're running around on site. Motor horsepower, you know, we want to make sure that we match your electrical, the height, all the way line of sight, and you know, that air discharge, we're trying to look at architectural considerations, all those things. And then also your likely rigging path, you know, is it simple, or do we just park a crane next to the building and we're there? Or is it coming up in a helicopter, or, you know, is it a knockdown unit in the basement and putting pieces down in an elevator? So, you know, let's get it out there with you and check some stuff out. All right, this is kind of akin to your question. So VAPCO does exact direct replacements for VAPCO units, or any of the products we've ever sold. So you get on site, we get a nameplate, we can usually pull up a faded drawing just like this one, and then we'll use that same drawing to build you a brand new one. So the old cut sheet will be identical to your new submitted cut sheet. So the dimensions and the weights and the connection locations are going to be exactly where they should be within pulses, right? And the tower capacity will be equal to what's there or better. But these are all units that are not in our catalog, meaning that, you know, the engineering team and the factory floor has to do a little extra work. So there is a cost premium. But these are great for units that, one, don't have a comparable catalog unit, two, they're in a really funky place, and the only thing that will fit. And then three, if you're going for like a super fast turnaround job, like, you know, you want to get in and out of there on a weekend, at least you know that, you know, all the connections are in the exact same place as that existing one. So we do not do exact replacements for our competition because, you know, we don't have any backlog information on there. So for any of the competitions, we'll be looking at our current catalog, but what makes sense. A note, I think in the 90s is when they started CP Cooling Tower Institute certification on performance. And anyway, so if it's built before the 90s, people used to use a lot of ledge factor. So we can't CPI certify the exact same performance for some of the old ones. Anyway, that's what we say, it's equal or better than what's sitting out there. The piece of paper might say something different if it's pre-90 or whatever. But we'll jump that ship when we get there. But
usually they replaced like 10 years ago.
it's out there. Yeah, you'd be so surprised. I've seen the
water right about in the water, right?
They should be.
You
know, the act is always like, well, it depends on, you know, your maintenance. And I think that's part of it, but also some of the environments that they're in. Like, for some reason, some all down ideas just last forever, and then sometimes, like, all seasons ones don't. But it just depends.
I don't have good stories, but we have good stories of guys running acid into their cooling tower and blowing a brand new tower. So there's all kinds of ways to break stuff. There's all kinds of ways to make it last longer.
Yes, absolutely.
Performance varies. Not with the tower.
Or longevity varies. Yeah, if you dump some acid in it, it's going away. Some other installation stuff, I mean, some of you guys have Mac projects. Cooling towers are not single point power, and that's for any brand cooling tower, that's just not us. So each fan motor and each spray pump, if you're on a closer cooler, needs electrical wiring to them. It's really your preference on VFDs, whether you want one VFD per fan motor, or if you want one larger VFD to supply 2 fan motors. So yeah, you get full redundancy, it's dedicated, lower first cost for the second option, but they give you whatever you want. Space heaters for fan motors just come standard on all of VAPCO cooling towers. You're not obligated to use them. They just do it because it's just easier for the factory versus having to submit and not submit on certain units. But pretty much it's, it heats up the motor so condensate and stuff doesn't sit on there, sit down in cold space. But it does require a 120 volt connection to energize that little space heater. I guess the caveat is if your motor does fail because of moisture gets into your motor, VAPCO won't cover it. It didn't work on this space, which makes sense. it won't void the cooling tower. Does that make sense? Like, you don't use it and it doesn't fail because water gets into the motor. The rest of it's still fully covered under warranty. Vibration switch. This takes some time, but it's a non-voltage. It's just between the switch and the VFD or motor starter. So the vibration switch pretty much if the fan comes out of balance and it starts shaking, you don't want this thing to keep going and fall apart. So if it starts shaking too aggressively, the switch will turn and the cooling tower fans will turn off to save the unit. You gotta be mindful of your steel. This is usually third-party supplied by your favorite person. Each person's on
I'll say, I don't think we have a favorite at this point.
No.
Right? That's a longer discussion.
Oh, okay. Well, that's a tricky question too. Yes, but like, you know, I think California is always tricky because we're in earthquake country, so we kind of lean on the local guys. We do have access to them through vibroacoustics, but they're not local, right? So I think there's, yeah.
That's half a joke.
Oh, okay.
Maybe 6%, 7% really.
If I could confidently come in there with my stuff, I would, but I would leave it because of earthquake land. In fact, the structural guys will determine a lot of these things. You know, height, I guess, is always an issue, so there is low height isolation configurations available, but yeah, just check with your third-party guy.
Or they're usually called saving brackets.
Yeah, they just kind of hang off the sides instead of sitting on top.
Oh, yeah, you're not here to present.
No, yeah. I'm just saying, my cooling tower's big. Buy me 6 extra inches with the low height isolators. Yeah. There's some plumbing code coordination to be done. I mean, if it's retrofit, there's probably already a drain out here, so there's no big deal. But if there's not, and you have to figure out, hey, how big of a drain do I need to size, or how much of a the line size I need from our makeup water, there's calculations for that, and it's all dependent on our cooling tower, so we can help that. Help you calculate those things. And
You can't blow down a leak drain?
Correct.
our drain is not there.
I was looking into this recently, but is a 1-inch air gap the minimum that you would need? An air gap is always required for the drain? Plumbing code.
Yeah, I don't know.
Okay.
It's in the place you need a gap. I don't know. You're asking what the distance is?
No, because like we have a job where there's just like it's like a direct pipe connection drain, no air gap, and I was trying to find the code that would tell us that we need it, but I know we need it, but I don't know why or like where it's talking about.
Plumbing code? I don't know. I don't expect.
Yeah.
I'm talking to
That's
get you
my,
out
that's
of
my,
there.
I'm only the equipment guy, I don't know anything about that. All right, cool. So Title 24 cooling towers. So the mandatory, requirements has to do with cooling tower efficiencies. There's a table that you have to reference about, how well our cooling towers are performing. They're pretty much all done, but you're gonna double check anyway if you're putting together the Title 24 sheets or whatever. You also need conductivity, controlled water treatment, which is related to figuring out your maximum cycles of concentration. It's pretty much how much you blow down your water and you want it to be as high as possible. And then you need a flow meter, overflow alarm, and high efficiency drift eliminators. The drift eliminators for VAPCO, they're above and beyond what's specified in your Title 24, so you're fine. So,
To stay on that, sorry, and this is unrelated to what EVAPCO will do for us, but the cycles of concentration, it's one of those things that's not really enforced in the code, and involves chemical water treatment.
So,
I guess you guys go.
later on. Okay, VAPCO is the only cooling tower manufacturer that will take your water sample and do the calculation for you. So we'll say this is the quality of your water. It'll determine what your cycles of concentration will be, and then we do all the calculations. We can help with these things up front.
So you say you take like city water from San Bernardino, whatever the utility is.
You take me a little regular water bottle, you fill it up with your makeup water out of the tap, out of the bathroom or whatever, and then we send it to the factory and they tell us what's up. Also, if you have a cooling tower out in the field and you're trying to help a customer and you're like, there's holes and fittings in my cooling tower, what the what? And so you can also take a water sample. You take the makeup water and you take the basin water. And we can send both of them, and they can kind of like figure out what's going on with your water. AKA, like, is your water treatment sufficient? Like, you know, what's going on with the water that's available at the site? Like, there's a lot of things that can be done. But that doesn't want to do that, and they do it for free. So you should totally take advantage of our generosity.
What's the turnaround time on something like that?
2 weeks. But for free, it's yeah.
And it's right. In an effort to sell chemical treatment.
Yeah. Well, two things. I don't know, we're kind of running out of time. But yes, 2 things. They're also the only cooling tower manufacturer that offers a water treatment product. And then the other side of it is, if it's our cooling tower and there's something wrong with it, we can defend our cooling tower. We're like, hey, your water's out of whack. But we also do provide factory-provided water treatment, and yeah, we'll dive into that.
Will be streamed soon.
So, don't have to memorize it, that's what the table looks like. This is also what the verbiage looks like, but it's all the things we just said. Just so if you're skimming through it, you know what you're looking for. The prescriptive requirements are fan speed control, so you just got to put a VFD on it. The cooling tower must turn down to 50% of the water flow. Ask us to verify that. 80% of the time it does, but 20% it doesn't, so just ask. And then that's the limit on the force draft fan, so anything greater than 900 GPM, you can't put a force draft cooling tower in there because the horsepower is known to be higher. There's caveats, of course, you know, but yeah, it's the general thing. There's descriptions on how to operate multi-cell fans. They pretty much want to keep all the fans on as long as possible, and then once you're at the minimum for all those fans, you can turn one off, and then keep going. Pretty much because you want to take advantage of all the heat transfer surface area, so more of the fans that we can use to keep the entire, you know, bank of cooling towers going with that. So, and then like even higher efficiency requirement for cooling towers than that previous.
That was recently defined, right?
Yeah. So
that's like the newest of
this is the 2022.
Yeah.
Well,
I never had any.
Because I didn't even know that until I updated it.
It's going to change again.
It'll change, and then it'll change again.
Are you going prescriptive usually, or
usually? Especially for change, or we do a lot of change out towers.
Yeah.
And then that's.
Yeah. So that's what the summary was of these things, but just what it looks like. All right, we're in maintenance. All crazy things. Okay, Adapco also, I'm telling you, they overthink cooling towers in a good way. Motor access is always from the outside of the cooling tower. If it's one of our smaller ones, it'll just hang off the outside. If it's one of our bigger cooling towers, they do it on this swinging arm, so we swing the whole metal motor out the door, and you can do what you need to do. They also extend the lube lines out to the, you know, doorway entry, so you're not climbing in there to go clutch the motor, which is great. It keeps you out of the moist, wet area, and that's if you have a shitty water guy. I said water guy. Okay, yeah, so we were mentioning the crossflow and counterflow. So the crossflows, yes, you can stack them all next to each other and like get the small footprint. But what happens when you got to maintain this one? This one in the middle. You got to shut down 2 other cells to get to that third one. And same if this one needs attention. So the way that Adapco likes to configure their ATs or their counterflows to have access to all the cells, regardless if one comes out or not. The crossflows, you're technically supposed to have some space right here, and every 2 you're supposed to have some additional space. So they're cutting corners here, but there's a penalty, right? Which means these 2 have to be off. If my fan over here needs attention. So, can you do it? Yes. Do you have to deal with the after effects? Yes. Counterflows, we also like them because you don't need to jump on top. Like our access ladders are right where the motor door access is, versus the other guys, you got to climb on top to get to the motor over there. So it's also, when we're talking about height, is always so critical. So even though your cooling tower dimension for the crossflows may measure to here, you actually really need that plus an extra 4 feet. So if you're trying to remain out of sight. So it's something that the crossflows have to deal with. Sorry. Okay. So Adapco has improved upon that cross-flow design. We have block bonded or bonded block fill. We support that fill from the bottom versus just letting it hang or sit on the floor. We have cold water basin covers, pretty much enhancing your ability to keep the basins clean. And then we have modular hot water basins, meaning you can pull the basin out without disturbing everything else. I think the next few slides just review those things. So the competition has these like hanging fill curtain type fill. So, they tend to sag or they separate or they become, weirdly spaced, affecting your performance and pretty much reducing the life of the cooling tower. That is block bonded fill. It's pretty much similar to our cross-flow fill. It's really robust. You can stand on it. It has multiple air passes through it, but it's a fully bonded piece versus having to like curtain draw all these single pieces. So yeah, you can see how the curtain kind of just sits on top of everything versus our block bonded fill, which is represented by this blue, is supported from the bottom of the basin, giving us some clearance access under there. So it makes it easier to clean the basin. These are also optional, like I mentioned, so you can cover the cold water basins so things aren't just falling in there and sucking up your basin of your cooling tower. This one's cool too, where they put together the modular hot water basins. I mean, you can move this whole thing out without pretty much ripping out the entire top of that cooling tower. So just easier maintenance, easier replacement than what our competitors are doing. All right, water quality. So we're going to talk about this. If you don't have good water quality practices, what happens to your cooling tower? And it's pretty much this. You get bush fouling, you get scale, you get algae, and all of that gunk, ends up going to your chiller or your, energy chiller, our application. So, reducing the life of everything downstream and also reducing performance of that stuff. Just more examples. So yeah, if you don't have any kind of filtration or water treatment, there is going to be debris in the basin. Like cooling towers are big air scrubbers, pulling the leaves and the dust and feathers and anything else that's in the air, and then it'll hit that raining water and it'll end up in the basin. So something has to be done. So cooling tower water quality is a two-pronged approach. You need both. You can't have one or the other because it'll cause a failure in one. The first one is filtration and the second one is water treatment. So filtration is going to take care of the big stuff. So dirt that comes into your makeup water, big air particles that are getting drawn in from the ambient air, and bacterial growth that results from all of this debris sitting in the basin. And I think our market is generally really good at specifying these and supplying them, so something I really have to sell on. But factory installed some super piping. There's different kinds. The ones we want are hydro boosters or high flow injectors. They're just nozzles. There's one that's just pipe and holes and it doesn't do anything. So if you see that submitted, it's not what you want. You want the ones with the nozzles, so it's creating the pressure to push all the dirt toward the filter. But anyway, having a pretty much 24/7, or at least whenever the cooling tower is operating, filtration system going, keeps everything clean. Reduces the maintenance requirements for the facilities guy and now for the races. Our product is Legos. We like them a ton. They're really easy to work with. They have a solids recovery vessel, which is pretty much a filter option, or you can put an automatic blowdown valve. So if some guy's not going to go out there and replace filters, just put an automatic blowdown. I guess the pros and cons is, you need somewhere to blow it down, so you need a drain versus a filter where you just blow up the filter and put it on back.
Is on that filter, is that like a cartridge filter, like a bag filter?
This one's a bag filter. If you want even more filtration, you can tack on another cartridge filter. So, but I mean, that's just all present. 99% of the time it's just, and it gets down to like 0.44 microns per multiple pass. And I think it's if you need the cartridge if you want to get down to like 10 microns or sub whatever. But that's kind of aggressive for what we're looking at. Okay, so that was filtration. So the other prong of water treatment is or water quality is water treatment, and it's kind of dealing with the chemistry side of water. So we're trying to avoid corrosion, trying to avoid scaling, and we're trying to avoid bacteria growth. Okay, so probably when you're jumping out on site, someone's water treatment thing is already out there, and it can vary about what you get because engineer specifies something and you just kind of get whatever at the end of the day, and whether it matches or doesn't match the spec, or the spec might not even make any sense. So you can get this piddly drum, which is not doing nothing, or you'll get a more this is a little cleaner system, but then you'll get some weird things that aren't actually introducing the right amount of chemistry. So it's pretty much critical to partner up with a good water treatment provider. There's some good ones, there's some bad ones, but it's one of those things that it's hard to tell who's working until it's not working. Yeah. Oh, this is what we were saying earlier. Utilize tobacco for water treatment, or let us do your water samples. They're free. There's 7 guys just sitting doing water. It's kind of amazing. Just slinging water samples. But yes, we do have factory options. We have solid chemical or non-chemical, and then you can put them on either open or closed towers. So for their solid chemistry, it's kind of like your medicine tablet, the dry tablet. Like the slide, there's a lot of things. Water comes into the tablet, it becomes a slurry. It forces the chemistry slowly out of that tablet, and then now you're ended up treating water at the end of that. But the nice thing is that instead of all these several 100-gallon tubs of chemistry, now you get it in a dry box. So shipping and risk involved on site with lugging around poison in barrels versus I guess poison in the box is less, but like you can drop that on your foot and be okay. You can't drop that.
I don't need an emergency shower with that too.
So that came up the last, just recently. No, because once it becomes that slurry and into the cooling tower, it splashes out of the cooling tower into your eye. So if you go non-chemical, then
Since the owner hires a different
then
they're going to bring it up with their stuff.
Yeah, exactly. Oh, it's the same thing. So, okay, if you're having a closed circuit cooler or a vacuum condenser, factory mount is solid chemistry. Look, like it's integrated on my unit, no footprint, all the responsibility is on us. Like plug it in, and like our guy comes in, does the startup and walks away. Open cooling towers, we do have this lovely skid. It's a little bit more involved. We had it on Natural History Museum. We had this on Herald Examiner, and we also had a water saver on Herald Examiner, which I'm not covering because that's kind of like cooling towers 301.
Sorry to ask questions.
Yeah.
Who services that when you install it?
So we install it and then we service it for the first year, and we give reports every 6 to 6 weeks.
And then do you work with chemical treatment providers to feed the machine with the tablets?
So for the first year, yes. Yeah, like we absorb all the costs for the first year of chemistry. It's already built in our price. And then our guy goes in and does the monitoring and then also the chemistry instruction for that first year. And they can continue with them after if they want.
Okay, so you provide that service after the first year?
If they give a contract to.
And like there's an option to buy continued service.
Yeah.
I was just thinking like, are the same chemical treatment guys that usually show up with 3 barrels able to use your product? Because we're we're kind of creating a system that requires tablets.
Yes, those guys would know what to do, but they would buy the tablets through it's like an online website.
Yeah. Is it proprietary, the tablets you have to use?
I assume so, but I don't know.
Yeah, usually we're just like working with a water treatment
Not
guy.
like crazy expensive though. I think most of the cost of the service, or like the visits.
Yes.
Yeah, the cost of chemistry is like.
It's just a really interesting often ignored part of our mechanical systems to this whole thing.
Yeah, so this we love, because it just makes sense. And then, like, you just pop the little, they're like kind of little cylindrical mesh bags, and walk away, and it does its thing. So what this needs to do, the person needs to do on site is to just check the conductivity levels, so they introduce the right amount of chemistry, and just make everything okay. But, I need to find out. I mean, solid chemistry, water treatment, like as a technology is not proprietary.
Yeah.
I don't know about, but I also think they can figure out like put the chemistry in there and work.
I guess usually the water treatment guy is already there for 10 years, and when we come in, we're just like doing whatever he wants with the new.
Yeah, I mean, as a mechanical contractor, you usually won't, I won't see someone purchase that through us, really. I do think the closer to cooler makes the most sense, though, as far as,
We just do nothing. I'm closer to coolers and the chemical guy.
yeah, I mean, I think that's where it lands, like, okay, chemical
Or why
guy.
would we add to our scope?
Yeah.
Or I agree. It's cool. It's great.
Yeah. I mean, I agree. But that's why I don't press it on the contractors. Engineers love it because they get a little risk management. Yeah. It's all on us. But yeah, so that's what that looks like. And then that's what the open ones look like. And it's fine. No. So yeah, you know what you're getting pretty much because it's a catalog thing. That's how it goes in. Oh, the other nice thing is if you're trying to meet Title 24, our water treatment products satisfy those things. And then, but yeah, I mean, gosh, we live and breathe cooling towers, and so, you know, please utilize us. $100 for every nameplate. That's legit. And then, you know, I'll follow up if it turns into this thing. But we're here to support you either way. I think we're just trying to push a little bit more. But, yeah. I also offer any factory visits. Alan and I are happy to take you to the factory, which is back in Honeytown, Maryland, which is next to Gettysburg, which is next to Washington, D.C. Lots of good stuff back east. All of our stuff is shipped and built in Madera, so just above Fresno. So as far as coordinating for your PMing, pretty much ships in a day.
No Madera press?
You can do Madera. It's a little. You guys can come to Madera. It's easier for me. I live that way. But like, they're funny. Half of, you know, I'm telling you, they overfigure things. They like to bring everyone back to headquarters and do the whole thing. So they're even more exhausted than what I put together. So, but you get to walk the factory floor several times, which is nice. And then, yeah, I think you guys have installed enough cooling towers. I don't, you don't have to do a job site visit, but yeah. Anything you guys want as far as cooling tower resources, you know, want to see any of those things, get us out on a job site, happy to walk it, and then we'll go from there. But, questions? Yeah?
I've never heard of 301 stainless steel. Why do you guys?
Why are we pressing that so much?
Or no, like why do you offer it?
I don't. I don't.
Okay.
Competition does.
But what is their reason for it?
It's cheaper.
Marley's 300 series.
Yeah, so pretty much it's like a workaround specification.
So I consider this.
Oh, it's stainless steel.
So Marley will swear by using 301 stainless, and we don't like it because it doesn't look new when you put it on the roof, and it's not as good. Which DMG will come here and say other things, but we tend to stick to, and you don't have to listen to me on this, but we tend to stick to adaptive over PAC for our towers because of that stainless steel on Marley, and because our field doesn't like the bottom connections of Marley towers. So that's not prescriptive. If you want to buy a Marley tower, you can do that, but just
also as far as like stuff belongs, like, I mean, even if you just pick them up like 5, 6, 10. Yeah, but I mean, 1976 would.
Yeah, I think they really got momentum 3 or 4 years into that.
But you know, it's funny, like, it's a box with a fan and still, right? But it's a product that needs a little more love and attention.
That's a lot of what we do.
Yeah.
Air conditioning.
I know. But I mean, I'm not surprised, like, in some regions they're moving toward, like, chillers or whatever. Because, you know, water treatment and everything, like, and water use is becoming a thing. But, I mean, for large, 500 tons and above, you're going to see it. And as you guys are, you know, doing service, you know, visits and field, reports for customers, like, we're gonna see these cooling towers out there, and they're gonna look for your advice on what to do. Oh, I guess the other prong of our business is factory authorized service, is our service guys, so if you need to buy replacement fill or whatever, or fan bushing or whatever, like, you can.
They'll work on any tower too.
Yeah.
See Marley, they're not directly to the APCO. So also if you're replacing a tower and say like the budget is super tight, we can get FAS to rebuild any tower. That's any BAC APCO, they'll get the parts and just refurbish it.
Even really old stuff.
It's just a good option. A lot of contractors go with that sometimes because they just want to buy a whole new tower. They just want to kind of abandon it. I mean, but it's a good option.
Yeah, like both the basins or something.
Yeah, the panels, the motor, the fill, all that. Yeah, we'll do all of that.
Yeah, if you want to coat a basin, so like we'll let them on by it for another year or two, they'll do that. I mean, it has to be within the tolerance quality of what's sitting out there. But yeah, like have our guys run out there and look around. And Alan and I aren't directly connected to the FAS sales, so it's just something that's available to you guys. But yeah. Awesome. Thanks, guys. Happy Friday. Oh, and also, new line cards. You guys want line cards?
Well, that's never nice to be able to talk about the quote. So that's something
The water quality of the world. There's a man box, which is like a blender, and the city of it is still has a water rise really high, that will raise, and then we have to comic one.
So what we will do sometimes is we will put a hole in for utility out of the factory, because we look from a service standpoint. If we buy the electronics for the annual, they're going to break at some point. And then we have to drill a hole after the fact with the easy flow. And so we'll drill with the easy flow. And that hole is cheaper to buy with the tower than for us to do.
From BAC, do they have an easy flow that they find?
I think so, yeah.
We buy it together,
Yeah, I'm guessing you can do it too.
Yeah.
If you want a hole in your basin, you get it in the factory.
It depends on, we have a lot of customers that we spend our whole careers up their facilities too. So those are the type of things.
Yeah.
Wow, because you're yeah, a little bit.
Yeah, absolutely. Well, I appreciate that.
So we can.
Those some of the, oh yeah, I talked to.
Oh, wow, okay. So you ever, you going now? Yeah. You guys have to go, like, drive through all the stuff, get back there. Oh.
Now I have another small. It's just a retrofit of air handler.
Did you get the new air handler or you put it in? Is it direct? You need the options?
No, it's already, yeah. It's already got it.
Already bought the air handler. Yeah. Kind of sell some gear. See you, Dave. See you, man. Alright, yeah, see you, man.
And then when you put in a bunch on there, all the suspended water that comes around the crowd just to overflow.
I just have to cut them.
Any kind of literature or anything.
I should have been able to cut those experiments.
You know what I'm talking about?
Yeah. I'll look into it. It's come up before, but yeah.
There's a lot of water.
Oh, yeah.
And then also,
You showed us before.
some of those towers evaporate like 2
That's
gallons.
dangerous.
It's
technically one of their tenants that's an officer is so he's like,
I would go that unit. That's scary.
I like it now.
I think it was.
I do too. It really is one of our best partners, like business partners, I would say. Like, hands down. We're always like really pissing off our other brands. How do you have more like tobacco? We're like, I'm not a tobacco. What? We're nice.
It was good. That was really good.
Oh, okay, great.
not everybody deals with towers, so it's a good refresher.
Yeah, I mean, that's the thing about this product, like, it's not an everyday thing.
And we're gonna see, as things go electric and water becomes less working, I see lots of towers.
They do, they're products, they just.
What's, are you engineering or?
I used to be the field right.
And I think a lot of people have relationships with EAC, we do a lot of EAC.
I've never seen it.
EAC and I know so hopefully we're giving you that feedback.
Thank you.
That's not based on anything in particular, that's just.
Okay, that's our job, that's our job at that point. But yeah, like, for instance, bring us to the dance and then we'll figure it out.
Yep,
Yeah.
exactly. And we should.
Letting it all out.
We shouldn't be just fine, which I don't think we are.
I don't think so.
No, I think you guys do a pretty good job.
Yeah. Or I probably shouldn't tell you that we prefer not to use Marlin, but that's. I've told DMG that.
I've heard other people say the same thing. Even our guy who came from DMG in here. I'm not surprised. They did sell a lot.
Well, I remember, so when DMG got Marley, they were just really, I don't know who had them before.
I don't know either.
If I thought about long enough, I could probably figure it out. But.
How old is Marley?
I don't know.
Marley's an old company.
Well, so you have
kind of like.
I think we ran it though with that like whole SPX thing, right?
Yeah. Well, so that's where we cross over, is we will buy fluid coolers from RSD, which sells or SPX fluid coolers, which are pretty much the Marley product. And we get better pricing from SPX than we would if we bought them through DMG.
Weird.
And I don't know why, and I think that's more Marley's background, maybe? I don't know. Because Mapco came right out of PAC.
Yeah.
It was like PAC ex-employees that moved down the road.
Exactly. They're like right above there.
Which is perfect because then you're getting similar things.
Well, the funny part is when they branched off, the Mapco went all counter, and then BAC let it down all crossflow. And ever, like, until like 20.
You can see your presentation. It's like hard not to have that in there.
Yeah, so 2010, they were hardline, and then they're like,
we gotta replace them.
Everyone needs to build each other's things.
Yeah.
It was really funny. I was like, the old guard.
Does VC really have a caterpillar though? I remember that they use. Like they never use.
VT too.
Yeah.
And that's, we do a lot of that.
Okay.
Yes, they do. Not as many sizes, but
Yeah.
enough to cover us.
Fiberglass towers. Why is it not a thing? Just because they're hard to work on?
The longevity and maintenance.
I've seen them in Mexico.
Terrible, and they're from Mexico.
But they should last longer than any type of metal, right?
Yeah,
In
exactly.
theory, I don't know if I
Our last company we sold Delta coolant towers, which is a high density polyethylene. And you hear them? Yeah.
Here you go. No.
You've told me this before, where were you at before?
Sigler.
And you were up north.
Up north.
Because I think, I think Sigler sold drinks at some point too.
Anyway, you can see it. So,
Those tower manufacturers move around, the fiberglass ones, and they don't ever seem to get play unless it's some crazy, that way elevation.
yeah, the fiberglass, like, you know, it's sitting out in the sun, so the fiberglass degrades over time, and then as well as the fiberglass degrades, you know, the fibers kind of protrude, you know, you've seen fiberglass come apart, and then with water and stuff sitting in there, it just rips apart, and then depending on the, you know, fiberglass quality, if it's letting any light through, algae's gonna be in there.
Yeah.
So, but as far as like resistance to whatever
Rust,
chemicals,
it's not gonna rust.
it's not gonna rust, but it's also subject to UV.
Yeah.
You know, the light thing, if it does make it into the basin, it's a petri dish.
It's just an interesting
I've heard that
disruption.
flammability part
Oh,
too.
it's also super.
So I was trying to sell fiberglass, plastic towers, and engineers and others was just like, so if there's a fire, like this is gonna be a
It's
catalyst.
also not like
Full of water.
Yeah.
It's weird though.
Your roof is made of PVC.
Yeah,
So
sure.
cooling towers made out of wood back in the day.
Yeah.
Fire all the time.
They caught on fire?
Yeah, even though they were like saturated water, so that's why they went steel.
Uh-huh.
Yeah, it started off.
I mean, steel is better for us because maintenance on a fiberglass tower would be terrible for us. Or what I've heard.
And they're also not like hodgepodge shaker tables.
Yeah, I think we're going with it. They're not as modular either. It's very hard to place components. So you get the tower and it's all one rotationally molded piece. So you don't have a basin in this. You just have like this big, they don't have a basin in that, but it's not as like easy to sort of.
And our techs don't know how to work.
Yeah, and then think about where's the access doors, where's the louvers gonna go, all that stuff.
Yeah.
Yeah, so it's just all those things. Also, they're just, well, lucky for us, they really just never did anything.
Yeah, it seems like there is and I'm not pushing for it, but it seems like it would be interesting to do all of your open tower stuff in plastic. Because I've heard contractors doing like PVC for bigger, and using metal towers.
Yeah, yeah.
But if you got rid of metal completely on the hot side of your chiller, that'd be kind of interesting. I'm not going to do it because then we're not going to do that for the first time out of here. But I would watch somebody else do it and see what the building is.
I know the mindset. It's like, we've always done metal, I'm not going to be the first one.
Or we got plenty of stuff to break on the heat pump side of things. I'm not going to do that.
Actually, as a manufacturer, they can get more expensive. Oh, yeah. As well. They're like, compared to, because they're, I don't know.
Yeah. I think well, I've never even taken those.
Well, I used to try to sell them, and they would go against like, you're 40% high.
Hey Brian, I assume that the Legos thing at the end of the month, we'll probably have to push it out, I assume.
Okay, yeah, that's fine. I haven't thought about it.
Okay,
so,
well.
Yeah, I deferred it to future Brian, and this week has been.
Why is that you, or?
Or we could still do it.
There's something on the 28th?
28th. We were going to try to bring a Legos trailer, but.
It might be good to spread it out anyways.
Yeah, that's what I was thinking.
Yeah.
Like, it's a little too soon.
Yeah.
Or this is good for like FaceTime with this group, and I think you'll get.
That's what I was thinking. I was like, it's a little too close. And then
we can get that little trailer.
Yeah. We'll figure.
Yeah, I almost took the trailer home last time.
That was funny. I was like, no one's going to pick it up. What are you guys doing over there? But thanks.
Just a stupid
You almost use
the only temperature.
You almost put it on a job.
Yeah, thanks for the free fan.
It was installed, it was running.
Yeah.
At least the concept's proven then.
Yeah. Have we put in any QPAC stuff? We haven't. Just the
We're trying.
What were the fans we did at POTS? Those were
Those were
bigger TMI, yeah.
We did put together a QPAC option, but they decided to do the TMI.
Yeah.
TMI also moved away from that, and now they make a similar to a QPAC option.
Okay. I really think at some point that's going to make a lot of sense for us because we retrofit a lot of these fan rooms, but we don't.
Yeah, we did it all the time.
A lot of times we don't touch the fan.
Yeah.
Yeah, I don't know.
Just these facilities and stuff is when they're going to pull a trigger and all that.
Well, it will change the coil, we'll change the
Yeah.
compressors, we'll change everything else, and we will keep the same fan. And it's like, hey, there's a payoff for that fan. So.
Yeah, exactly.
Yeah.
Well, the opportunity will happen.
Yep.
Wait for the right one.
Yep.
Does the gate open, or do we find?
So the gate will open if you drive at it. If not, I can open it for you.
Are you on the inside or the outside?
I'm on that side too.
Yeah.
We can go out this way too.
Oh, we'll just go around.
We can circle.
Yeah. Okay, cool.
All right.
All right, thanks, Brian. Until the next time.
Good to see you.
Yeah.
See ya.
No,
you're good.
I don't know what's left. Probably falafel.
Do you have the paper with the layout? Or is this the thing you passed out?
Oh, yeah. There's two things.
Probably have it already.
Well, this is updated for that new Title 24 stuff I just learned about. I was like, oh, there's new stuff.
This is ignored. So, or the reason I interrupted your presentation over and over is too often we price these things out and then they come to me to put together plan check drawings. It's like, hey, should we just not put Title 24 on the plan to see if it gets brought up? Because it doesn't happen a lot. But,
Yeah.
And
Yeah.
sometimes it doesn't matter because we're not permitting it or it's not.
Yeah, it's just like straight up.
It's just a growing and growing gray area, and it's my job in the company.
At least for us, we're always compliant. I mean, unless we're doing the forced draft. So, I mean, at least they have like a ASHRAE compliance, which usually kind of
It'll
shows
show
you the
it's middle.
GPM per horsepower. So
Yeah.
I usually just like, as long as it's not over 60.
Yeah. Fun. See ya.
Alright,
See ya.
Want to eat here? You want to take it to the office? You're gonna head home? What's your game plan?
I'll just eat it here.
Yeah.
And then head home.
What am I doing that? Training. You want to?
Oh, like right now.
Yeah, like right now. What is he doing it on? These? No.
We have these printed panels. I actually really wanted to.
Let's just take the food and go back to the office.
Yeah, let's go. By the time we get there, we're gonna miss it though.
You can always jump on your phone. That's what I do.
Yeah, I'm jumping on there right now.
I was like, man, two trainings in the same day? That's all good.
So, do you want to split this up? Because there's a Euro meat left, and there's 3 falafel. Actually, you can just take the meat one.
I'll take whatever's.
I'll take the falafel. This is good.
Okay. I'm gonna take those other two.
Take these.
What's in there?
Bunch of pita bread.
Oh. Right.
You mind helping me take the sodas?
Yeah. Did you bring all these?
Yeah.
Bring them home, Brad.
Yeah. Or just for the next one. It's also the bag. I don't know if it's easier to throw it in your bag.
Oh, yeah. Yeah, absolutely. Well, thanks for presenting.
Yeah, no, it's good.
Appreciate it. Felt kind of weird just sitting there, but.
No, and you chimed in at like certain things, which was great.
Yeah.
Exactly what we want. Was it good? I don't know. Yeah.
That's great, yeah.
Yeah. Okay.
I always hate basic presentations sometimes. It's like, you know, most people in the room kind of already know what you're talking about, but there's some that just don't know it.
Cooling
So,
towers is
so
like,
it's important to.
someone only sees it once every never.
Yeah. Dang. Diet Cokes go fast. I absolutely despise Diet Coke.
I don't know. The last time we came, we were like, oh, I didn't diet. I was like, oh, I guess I gotta get diet next time.
Yeah. People love Diet Coke. Like, it's a
Yeah,
very,
people
like,
love it.
love Diet Coke. I have an uncle that
That's all it is.
that's all he's drank his whole life. He looks so good. he's like, I don't know how old he is. He's like 75. And he's not even fully grayed out yet. He still doesn't die.